Okay, we need to finish this problem here, continued from 10.1. Okay, so up here we've got a relationship, 1.3 times as long to go 5 miles up the White River than to return. So you see there's going to be a relationship between the time it takes going up the river and the time it takes going down the river. And we can write that relationship right here. So this is the time it takes going up the river. That's this TU is going to be 1.3 times going down the river. So you see in this particular one here, when we solved for TU, we just went ahead and substituted the TU. This is our substitution, 1.3 times TD. Now remember, this up here was the rate going upstream, and then this is the rate going downstream. Okay, I should have actually stated that a little better there. So all we need to do now is basically just plug in everything that we have been given. So we've got the rate going upstream, right? The rate going upstream, it says, where's it at? Kayak cruise at 5 miles per hour. Oh, we're going a distance, sorry. That's what I wanted to get at here. We're going a distance of 5 miles. So du is 5. And then we've got the rate going upstream as 5 minus x. Okay. And that's equal to, now we have the 1.3 here times the time going downstream. But what is TD? That's going to be dd over rd, right? And that which is going to be 5 miles still. And then of course the rate going downstream is, well, I better just say that it is 5 plus x. And so now we have an equation here that we want to solve for x in this problem. And at this point I'm just going to go ahead and tell you what I'm getting for x. Let's see here for a second. I'll tell you what, we'll do a few manipulations here before we get to that point. And let's see, 5 times 1.3 is 6.5. Right, and then 5 minus x. Okay, and then 5 minus x. Okay, well, I'm getting x is 0.625, 0.6 or 652 miles per hour, let's say. Okay, that's what I'm getting for x. So try to solve that and see if that's what you get. Okay, see if that's what you're getting. Huh. Let's see. 32.5 minus 6.5x, and then so 5 plus 6.5 is going to be that, and okay, so then we got 32.5 is 25 divided by 0.652, yeah, that's per hour. All right, let's move on to the next problem. All right, this is actually, don't have the number written up here, do I? Doesn't look like. This is 10.2. Okay, and I don't believe we're going to be able to finish 10.2. Doesn't look like. And so what I'm going to do here is I'm going to, let's see, let's get back to here. Okay, it says how long will it take Jill alone to fill the bucket, and I'm going to go ahead and tell you that it's you should be getting 2/3 hours here. Okay, you should be getting 2/3 hours, and I think probably what I'll do is kind of halfway fill this out. Alright, I think that's what I'll do. Okay. Anyway, so let's take a look at this. Jack takes 2 hours to fill up the bucket of water. With the help of Jill, the bucket can be filled in a half hour. How long will it take Jill alone to fill up the bucket? So the rate of Jack is equal to Jack takes 2 hours, but we're going to call that part a half. Okay, 1 being the whole, it takes him 2 hours, right? Bucket per hour. So you could say this is the bucket per hour, and then the rate for Jill, better put Jill, is going to be equal. This is the rate of Jill is going to be equal to 1 over t, right? We don't really know what the rate of Jill is, but it says how long will it take Jill alone to fill up the bucket, so t is what we are actually after. Okay, so the actual equation is going to be a half times a half plus 1 over t times a half, and that's going to be equal to 1 being the whole. And what you'll want to do in this problem here is you'll want to solve for t, and you should be coming up with 2/3. Okay, so this is the part of Jack plus the part of Jill is equal to 1. Is equal to 1. Okay. Anyway, solve for t, and that problem should get to 2/3. How long will it take Jill alone to fill up the bucket? All right. Okay. So let's quickly move to the next problem. So this is 10.2. You should be able to work this stuff out, hopefully. All right. You should be able to work these problems out. All right. Let's go over here. Oh, this is my favorite problem, the bunny problem. I hope I can get this one actually worked out here. This is my favorite problem. This is the bunny problem. Yeah, the bunny problem. It's actually pretty easy to do. Okay, it's just a couple ratios is all we gotta deal with this problem here. All right, the bunny problem. Okay, so let's take a look at this last problem. Now, yes, bunnies like cereal. I'm not kidding. And my bunny, named Sparky, well, he likes a mixture of cereal. And this particular mixture contains 2 pounds of Cheerios, well, we're going to say X pounds of Chex and Y pounds of Fruit Loops in a ratio of 1 to 2 to 3 respectively. In other words, this number here is 2 pounds of Cheerios, and then this number would be Chex and Fruit Loops. Okay, and he also likes Count Chocula and a bunch of others, but I just threw in these are his favorite. Now, you don't want to feed your rabbit cereal all the time. Okay, it's just a treat, or they'll end up with no teeth. Alright, so this is the way this works. I had to throw that in there because probably get a comment or two. Somebody's like, "Don't be feeding your rabbit cereal. That's bad for your rabbit. A bad rabbit." Okay. Anyway, we had a hint going on here: 1 to 2 and 1 to 3. Basically, all this is, now this is extremely useful. I use this in a lot of situations what we're about to do here. But we can rewrite this 1 to 2 ratio right here, yeah, as 1 over, if I get my pen to work, 1 over 2 is equal to, okay, and what do we got? What are we doing first? I almost forgot. X pounds of checks. Okay, so X pounds of checks. Yeah. X pounds of checks. Burp. Anyway, so we have 2 pounds. Now don't get this 2 mixed up with this 2. Okay, these are completely two different things going on here. Alright, but it's a 1 to 2 ratio. A 1 to 2. 1 to 2, 2 to 3. Well, anyway, this 1 to 2 ratio, so this is 1 over 2 is equal to, and then take this 2 here, put it here, okay, over X. So we're comparing both these ratios here. We got 2 pounds of Cheerios to X pounds of checks. And so basically we have an equation here you want to solve for X. So hopefully that you know how to do that. Now remember, there's a quick way. Just flip these fractions. We're trying to solve for X here, and then multiply both sides by 2, and therefore X is equal to 4. Alright, so you'll want to get you'll want to mix 4 pounds of Cheerios. Actually, he likes Honey Nut Cheerios. Honey Nut Cheerios. Alright, so let's now take a look at this other one here. We got 1 to 3. Right, 1 to, did I say 1 to 3? Yeah. That's right. A 1 to 3 ratio. But we're going to do this 1 over 2. 1 over 2 is equal to, and then we're doing 3 over X. 3 over X. That's that 3 over X. Oh, you know what? I may have told you something wrong here. Yeah, I think I probably did. This 2, okay, is that 2 right there. Yeah. This 2, I think I might. This 2 is this 2 right here. Alright. This 2 goes to this 2 here. I may have had that backwards. Sorry about that. This 2 is going here. Alright. And then this 2 is going right here. Got that? Okay, so we're comparing once again. So this is 2 pounds. So if this was like 5 pounds, we'd be putting a 5 here. Alright. So we have a 1 over 2. That's this 2 here. And then of course right here, this is going to be 3 over however many pounds that we got going on here. So then we just solve for X once again. Okay, and we're going to flip that around. Sorry about that. I think I might have told you wrong that first time around there. Sometimes I get confused. So X is equal to 6, right? And this is going to be Fruit Loops. Fruit Loops. Have you ever had Fruit Loops? Anyway, that's going to be Fruit Loops there. See? So we have a 2, right? 2 pounds of Cheerios. Wait a minute. I got that. Oh my God. I think I'm asleep over here at the wheel. Sorry. We got 2 pounds of Cheerios, 4 pounds of Chex, and 6 pounds of fruit, cross my T there, Fruit Loops. 2 pounds, 4 pounds, and 6 pounds. Now does this make sense? A 1 to 2 to 3 ratio. 1 to 2, then 1 to 3, you could say. And so let's see, 2 over 4 is a half. What's 4 over 6? Or 2 over 6 is a third. 2 over 6. So you see, if you reduce these things down, you got 2 over 4. That ends up being a half, or you could reduce that to a 1 to 2 ratio. And then 2 over 6 is a 1 to 3 ratio. You see that? Turn these into fractions here. 2 over 6. You got that? See that? Yeah. Over 2. Anyway, another way of looking at that. Alright, so there you go. Of course, you don't have to be doing mixtures of cereal here. We could be talking about just about anything you can think of. Right? Just about any possible scenario you can possibly even think of there. Alright, check it out. Mix up your bunny some cereal, man. He is gonna love you forever. But don't feed your bunny cereal all the time. That is very bad for the bunny. I'm telling you, just a very great once in a while. And I'll be honest with you, don't feed your bunny Fruit Loops. You know, the best thing to feed your bunny, you want to do anything, is feed them oatmeal. They love raw. Don't cook your oatmeal. They love raw oatmeal. You know, I had to just try to come up with some kind of mixture problem here using ratios, and I really don't feed my bunny this crap. Now, every once in a while I give him a little Chex. He loves Chex, but he gets this all the time. Raw oatmeal. Alright. Okay, well, that's enough for this section here, and I shall see you in the next section. I think we're doing inequalities or something like that. Alright, and I'll see you in the next section. Bye.